Good morning. Unfortunately, I'm not in today, so you guys are stuck watching one of my videos. Alright, we're going to be going over simplifying radical expressions today. So we've done a bit with this, but we're going to take it a step further. So let's take one of the examples we've worked with already. Square root of 45. Except instead of just having the square root of 45, we're going to throw in another term here. And let's come up with a good one. Okay, times the square root of 80. Alright, what we're going to learn is how to simplify something like this. Now, we've learned how to take each of these radicals and simplify them, so we're going to do that. Now, we're going to take that square root of 45, we're going to break it up into two factors. Perfect square root factor we love, square root of 9, square root of 5. Okay, now we can simplify the square root of 9, we get 3. And we're just left with the square root of 5. Now, we're going to take it a step further and do the one over here, square root of 80. Now, I'm going to break that into two perfect squares. Now, you can think this through, but believe it or not, there are a couple of good factors here. I'm going to jump right into the largest square root factor, 16. And guess what? The other one is square root of 5. Think that's a coincidence? It isn't. Square root of 16, we all know, 4. And then we are left with the square root of 5. If you notice, we were subtracting these at the beginning, so we're going to take the subtraction sign and bring it down here as well. Now, guess what? We can simplify this. The cool thing to recognize is these are just like terms. And, oh, that was awful. Let's see if we can undo that. Sweet. Okay, we undid that highlight. Now, if you notice, they both have the same radical. This one has square root of 5. This one has a square root of 5. So you're going to treat these like terms. You're going to subtract the coefficients. Now, our coefficient here is 3. Coefficient here is 4. If I do 3 minus 4, I'm going to get negative 1. So, let's erase that. Go back to the pen. There we go. Now we're in business. Black. Okay. So 3 minus 4 is going to give me negative 1. And I'm going to keep that radical of square root of 5. And that's how you simplify these. Basically, what you're looking for is a common radical, common term inside that radical, and then you just add or subtract your coefficients as needed. Let's try another one. Okay, we're going to try another one here. So let's try this. We are going to do square root of 50. And we're going to use addition this time. We'll do plus the square root of 32. Alright, so I'm going to have to break each of these up. I'll start with the square root of 50. If I break this one up, I'm going to get, let's see, perfect square of 25, square root of 2, like that. So I'm going to continue working with that. The square root of 25 is 5. Left with 5 times the square root of 2. Looks good. Now for the next one, we're going to do the same thing. Hey, square root of 16 times the square root of 2. I can solve the square root of 16, get 4, and left with 4 times the square root of 2. Now I'm going to add these. Now again, what I'm going to do is I'm going to take those coefficients, and now since they're being added, I'm going to add them together. So 5 plus 4 is going to give me 9. Oh, I want to do that in pen, not with my highlighter. And then left with 9, square root of 2. And that would be my final answer for this. So it's pretty basic. As I said, it's just like combining like terms. Your goal is you just want to have the same term inside that radical. Like, it wouldn't work if I had like 5 times the square root of 2 plus 5 times the square root of 3. I couldn't simplify that because if you look, these radicals are different. So this is as far as I could go with something like that. Even though my coefficients might be the same, the radicals are different. Can't combine them. All right, we're going to try another one that's a little bit harder, but I think we can handle it. All right, let's try this one. We're going to do, all right, square root of 12 plus square root of 18 plus square root of 75 plus square root of 8. Cool. All right, let's try this. Start breaking these up. I'll start with the 12. Square root of 4 times the square root of 3. I can solve the square root of 4. I get 2 times the square root of 3. All right. Now for the 18 here, I'm going to break that one up. The perfect square factor of 9 times the square root of 2. I can solve the square root of 9. Get 3 times the square root of 2. All right. Let's try the next one here. Let's see. I'm going to break this one up. Square root of 25. Square root of 3. Break that up to 5 times the square root of 3. And then for my next one here, I'm going to break that up. Square root of 4 times the square root of 2. Solve the square root of 4. I get 2 times the square root of 2. Now I got a lot of terms going on here, and they're all being added. But again, just treat it like terms. You'll notice that I did the like terms in the same color. I did that on purpose. I figured it'd be easier to see. I've got 2 times the square root of 3, 5 times the square root of 3. If I add those together, I'm going to get 7 times square root of 3. All right, now I'm going to take my other ones. Hey, square root of 2 here is my common radical. So if I add 3 and 2, my coefficients, I'm going to get plus 5 times the square root of 2. As we talked about before, now we're left with 2 terms, different terms in the radical. Guess what? I can't do anything because I've got square root of 3 here, square root of 2. Can't combine it any further. So my final answer for this would have to be 7 times the square root of 3 plus 5 times the square root of 2. And that's basically what you're going to be doing after this. Now, some of these you might have some variables inside the term as well, like what we were working with yesterday, but same thing. Just simplify them. If they got common terms inside the radicals, then guess what? You can add them. They're like terms. If not, just leave them as they are. Cool. Good luck with this, and once you get finished with the assignment, I do have an extra credit assignment posted on Math Excel. I will count as a quiz grade, so it could help you guys out if you do it. So if you get finished early, it's a great thing to start. The extra credit assignment will be due, I believe it's the first week of April, so you got plenty of time, but today's a good day to start. All right, take care.